Hello guys in stats. This is a little review on the first half of the chapter to help you prepare for your test. So I'm going to go nice and slow, and I want you to write the extra stuff down on here as well because I think it might help you. So first of all, you learned how to make a Venn diagram. Not a Venn diagram. Actually, Venn was first. It's on the back side, but a tree diagram came next. And with a tree diagram, what you're doing is you're standing here and you're about to make some choices. So I like to put a little person there. And it depends on the choices. You have to read the problem. At a roadside food stand, the meal options are, the first thing they ask you is, would you like Coke or Mountain Dew? So branch off and make your first choice. I prefer, actually neither, but I like Diet Coke. So I'm going to go put a little highlighter on my choice. Okay, I'm that choice. Now, once I've said I want a Coke, they're going to say, do you want a hamburger or chicken salad? Well, or chicken sandwich. So I'm going to choose between a hamburger and a chicken sandwich. Someone else might have chose Mountain Dew, but then they still have to pick a hamburger or a chicken sandwich. So I think I am in the mood today for chicken. So I am that yellow branch of the tree. Last up, they say, what side do you want, fries or onion rings? I hate onion rings, so I am definitely going to be a fryer. So I'm going to put me right here. I'm this one possible choice or one item in the sample space. All right. So there's my tree diagram. When it says how many different outcomes are possible, this yellow is one possible outcome. But maybe Nick is like, no, I think I would go with the chicken, but I mean not chicken, a Coke, hamburger, and I do like onion rings. He would be this blue route. He's one other. Notice that's two different people making two different choices. When it asks how many, what you can actually do is just add up the leaves. 1, 2, 3, 4, 5, 6, 7, 8 on your tree diagram. Now, tree diagrams get really messy to make when you have lots of different choices. Notice off of each of these is just two choices. But like, what if I had 5 toppings to pick from? My branches just go forever. So then we have what's called the fundamental counting principle that says when you're making those choices, you can just say, well, I have 2 choices for my drink, 2 choices for my sandwich, 2 choices for my side. I'm going to pick a drink and a sandwich and a side. And means multiply. So you'll notice I get that same 8. Now when it asks for the sample space, that would be a branch of the tree. You could have been me, or you could have been Nick. So let's put them both on here. You could have been me going going Coke, chicken, fries, or you could have been him going Coke, hamburger, onion rings. But you have to list out each route along your tree diagram. Like that one, that route, all 8 of them would go in there. Maybe you chose Mountain Dew, chicken, onion rings. You put MCO in your sample space. So let's suppose somebody's birthday is March 15th, 1965. And if I asked you, what's the sample space for the digits in that birthday? Then you would say, well, there's a 0, there's a 3, there's a 1, there's a 5. You wouldn't list the 1 again. There's a 9, the 6, and you wouldn't list the 5 again. So those are the sample space for the digits in that birthday. Don't list them twice. Just like I wouldn't put my Coke, chicken, fries in here twice. So make sure you keep each one in your sample space distinct. So on this one, you are making choices. We're going to get a new curriculum here, and we have to pick which stats book do we want to use, which geometry book would we like Elk River kids to use, and what trig book would we like them to choose. And we have to decide, we have to make a choice. Now we could start and put our little person and make a tree diagram, but wow, like 6 different geometry books branching off of 4 different, that's a lot. So we're going to use that fundamental counting principle that says we're making one choice for statistics. We're going to choose a geometry book and then choose a trigonometry book. There are 4 different stats books, 6 different geometry choices, and 3 different trig choices. So what we do is we say we have 4 and 6 and 3. When in doubt, multiply. Or means add, but we have very few ors in this chapter. So when in doubt, multiply. And that equals 72. That's how many branches would have been off your tree. That's why tree diagrams are great for the visuals, but if you're making lots of choices, you should probably just put those slots down. Next up we have our combination, permutation, factorial stuff. So if you're arranging all the letters in this word, so now I want you to write this. If arranging all, then we use the how many choices factorial. Remember why, and again, this is review for the test, so I'm kind of explaining more than what's written on here. But if I'm going to arrange these letters, there are 5 distinct choices for the first letter. But once I give that tile to somebody, there's only 4 choices for the next one, then 3 times 2 times 1. And 5 and 4 and 3 and 2 and 1 is actually 5 factorial, so you can use the factorial key. But this one, I'm not arranging all. Had it said all, that's my answer. It says 3-letter words. So you have 5 letters available, and you are choosing 3. And that's where you have to decide if it's a P, a permutation, or a C, a combination. You need to know the difference between the two. For the permutation, the order matters. For a combination, the order does not matter. So think that that spells palm. Order matters. For a combination, order doesn't matter. All right, so we have to decide. We are going to do 3, but are we going to do P3 or are we going to do C3? That's the question, because they're different numbers, and I'm going to guarantee you if it's multiple choice, they'll both be there. At least that would be what I would think, right? So we are going to take 3 letters and rearrange them and decide if the order matters. So if this is our 3 letters, what I'm asking you is, does it matter if you went H, A, S? Is that a different word than if you did A, S, H? They are different. The order mattered. So I'm going to choose a permutation, and that's where you'll go to your decimals. You've been using your calculator all chapters, so if you need to review that, that's in a previous video. I'm not going to bring my calculator up. So how many license plates are possible? If each plate must have 3 letters, a letter and a letter and a letter, followed by 3 digits, digit, digit, digit. So you have to figure out, well, how many could be the first letter be? Well, there's 26 letters in the alphabet. Maybe your license plate starts with a T. But it says repeats are allowed. So the second one might also be a T. So you still have 26 to choose from. Maybe it was TTT, so 26 to choose from. Digits are what you see on your phone. 0, 1, when you're typing in a phone number. 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. There are 10 digits. So maybe this was a 1, but even if it was, I could repeat it. Now if it said are not allowed, then we'd have to go 26, 25, 24. And we'd have to go 10, 9, 8. So this right here on the bottom is if there was no repeating. And remember, when you say and, you multiply. So I have 26 choices for the first one and 26 choices for the second one and 10 choices, 10 choices. So we just multiply it all the way out. All right. And that's a huge number, lots of possible license plates. If there, makes sense, right? Think of how many drivers there are. If there are 10 people in a group, 10. In how many ways can 4 be chosen? And you have to decide, does the order matter or does it not? So you actually have to put yourself into that situation. So there are 10 people, and I'm going to choose 4 to be on my committee, the prom committee. And my choices are Alicia, Sam, Kaden, and Bill. Does it matter if I chose Sam, Alicia, Bill, Kaden, or is the committee the same? You should say that doesn't matter, it's the same 4 people. When the order does not matter, we do a combination. So in what situation does an order matter? Watch the next one. We're going to have 8 people on our board of directors, and we're going to be choosing 3 of them, but we're assigning them a role. So back to Alicia, Sam, Kaden. If I say you're president, you're vice president, and you're the treasurer, that's very different than if I say, no, you're vice president, you're treasurer, and you're the president. See how that's changing the order matters. So that becomes a permutation problem, and you do those on your calculator. So last up, the Venn diagram. If you don't make it correctly, then you're not going to be able to answer any of the subsequent questions. So remember when we talked about this, I highly advised you to read it first and see what choices you're making. So these are 35 students asked about what candy they got on Valentine's Day. 22 said that they were giving out candy hearts. 12 said chocolates. 5 said both. And I bet there are some that are like, neither. I didn't get either. All right. So where we build it is from the both. We build it from the middle. So write yourself a little note. Build from the middle. How many got both? Okay. So when it says 5 got both, the both is where these intersect. So I'll shade that in, and that 5 should go in the middle. If they then said 6 didn't like either, you'd put it out here, but they didn't tell me that in this problem, but sometimes they do. So build from the both, then do the neither, and then read the rest of the problem. So there's 35 surveyed, so whatever numbers I put in my Venn diagram, and there's always 4 numbers, there's the 5, and then what I'm going to put in this lobe, and outside. So there'll be 4 numbers that you fill in. It says 22 said they got the candy heart. So let me go change my fingertip here to a blue, and let's make the candy hearts blue. And there were 22 of those. 12 said they received the chocolates, and we'll make that purple. All right, so it matters whether they get only chocolate or just chocolate and hearts. So let's see, 12 said they received chocolates. That means 12 have to be in this purple circle. Well, there's 5 already in there. So I have to say, well, there's 12 who got chocolate, but 5 got both. And the ones who got both still got chocolate. So you have to subtract. You have to do 12 minus 5. 22 said that they got candy hearts, but again, there's 5 already in there, so we have to take those 5 out, and you can do that on a calculator or whatever. Now, if it said only hearts, then I put a 22 out there, but it said hearts, not only hearts. And we're going to run through another one of these too when I'm done. I'll just change it up a little bit. So now the only missing number is, well, how many are outside of these and didn't like either one? Well, you have to see, well, that's what this is saying. How many liked hearts or chocolates? Well, the 17, and you don't really need to know this notation, I don't think, but if you do this, N means the number. This means hearts or chocolate. This would be hearts and chocolate. All right, and that would be 5. So I have the 17 who liked only hearts. I have the 5 who liked both. If I said, for these 5 in here, by the way, if I said, hey, did you get hearts or chocolate? You'd say, yeah, I got both. So they get included as well. And we add that all up, then we get a, 29. So 29 of those students in that class have been accounted for. So how many were like, I didn't get either? Well, they have to be 35 students total. So if I've got 29 accounted for, right, I'd have to say, well, there's 6. By the way, you know if you've done this right, if your 4 numbers add up to the total surveyed. So always double check that because it can throw everything off. So how many had only? Now that's important. It didn't say candy hearts, it said only candy hearts. So I can't count the 5 who had both. That would be the 17. Only chocolate. Only chocolate. Neither is the ones outside. So we're going to try one more of those. So for the kids who were here, we were talking about country and rap music. And I said, suppose I asked 20 people if they liked country or rap music. Then your Venn diagram is going to look like this. There's a 20 out here because I know they have to all add up to 20. I've got a country circle. I have a rap circle. So let's see if we can fill this in. Suppose I tell you that 7 like only country, 3 like both, and let's say 9 like rap. So remember what I said, we build it from the middle, 3 like both, 3 like both. 7 like only country, so that means they are not in the both, they're only country. So those 7 are out here. 9 like rap, now it doesn't say only rap, it says 9 like rap. So there have to be 9 accounted for in this circle. So because 3 are already in there, I'll have to subtract. So there I've got my 7 only country, 10 like country, 3 are both, 9 like rap, and the only number missing is how many are like, I don't like either kind of music. Well, 7 plus 3 plus 6 have been accounted for. I've got 16 students who have responded that they like country or rap. My husband, however, doesn't like either one of these. He's more of a rock, 80s rock guy, so in classic rock. So he would be one of the 4 people who said, I don't like either. So build it from the middle. Understand if it says only, you're in the lobe that doesn't include the middle. If it said how many, then you include the whole circle. All right? The last thing we did for the first part of this test prep is we talked about rolling some dice, because that's a really common question. I don't know if you have a 4-sided, 5-sided, or 6-sided, so let's err on the 6-sided, right? So suppose you're rolling 2 6-sided normal dice. Okay? Let's suppose you have to make a sample space for that. Suppose you roll a black dice. You could get a 1, a 2, a 3, a 4, a 5, or a 6. Then you roll your red dice. Be careful that you put it down here. So I would always go like that, and then like that, and leave this top left empty. Somebody yesterday in class put their 1 up there for that. We were doing a 5-sided dice, and it threw off the whole grid. So there's red and there's black. Now when you answer it, it depends on what they ask you for. So I'm going to go in blue and finish off my grid here, guys. So I'm going to go like that. So you give me a minute here. Have fun. Right? I'm going to go like this, and like this, and like this, and like this. I'm creating all possible rolls. Now it depends on what they ask you. What are you looking at when you roll the dice? Maybe it's like, how many ways could you roll doubles? Well, 1 and a 1, a 2 and a 2, a 3 and a 3, a 4, a 4, a 5, 5, a 6, a 6. There's 6 chances, 6 ways, right? Or maybe it talks about the sum of the dice. And remember, sum means add. Or maybe it talks about the product, and that's where you should write this down. And product means you're going to multiply. Let's choose sum. So we're going to record the sum of the 2 dice in blue. 1 plus 1, 1 plus 2, 1 plus 3. And I always go down here because there's a pattern. So I can do 2 plus 1, 3, 4, 5, 6, 7, 8. 3 plus 1, 4, 5, 6, 7, 8, 9. 4 plus 1, 5, 6, 7, 8, 9, 10. Isn't this fun? And then 6, 7, 8, 9, 10, and 11, and then 7, 8, 9, 10, 11, 12. Now, if you were asked to list the sample space for the sums, remember you don't list any twice. So the sample space would be the 2 the 3, but don't list it twice, the 4, the 5, and it'd be all the way up to 12. Don't list them twice. Now if it said, how many possibilities are there for rolling, let's say, a 4? Then you would just go count up 1, 2, 3 possible ways to roll a 4. What number is most likely to be your sum? The one you see the most on your table. So 7 is most likely to occur, or I would see it the most. How many times would it be in my grid? 6. All right. Now if it said product, then I'd fill this in with 1 times 1, 1 times 2, but answering the questions are the same. All right, so that's it for the first part. I'll make another one, okay, and you really should watch it. It'll be for the last part of the chapter where things got a little trickier, so, but it won't be as long because this covered 1-1 to 1-4, and that one's just going to cover 1-4 BC, and then maybe a little more review. All right, so have a good one, guys.